In this lesson, we're talking about classifying and identifying triangles. Triangles can be identified and classified in multiple ways. We name triangles based on the attributes of their sides and angles. Because we're looking at the length of sides and the measures of angles, every triangle has one name based on one of these items. So we have two names for every triangle, one based on the length of its sides and one name based on the size of its angles. First, we're going to talk about the side classifications for triangles. If you have a look at this triangle here, you'll notice that it has obviously three sides, but it has three sides that are different lengths. We know that they're different lengths because of the numbers of tick marks that are drawn on them. Sometimes you'll have to measure the sides of a triangle by yourself, but if you're given something in a textbook or on a worksheet or in print or on a test or on a quiz, we'll try to make sure that you can tell if the sides are the same length or not based on the tick marks. So because this side has one tick mark, this side has two, and this side has three, they are all different lengths. So this is called a scalene triangle. And a scalene triangle has no congruent sides. And in case you weren't sure, that word congruent means exactly the same size, exactly the same shape. It means basically identical to. So congruent means congruent means exactly the same. And so a scalene triangle has no congruent sides, so that means none of the sides are the same length. Here we have two triangles. And each of these triangles, you can notice on this one that the left side and the right side of this triangle have one tick mark each. That means that each of those sides are the same length. And then on this triangle, this side has two tick marks and this side has two tick marks. And that means that those two sides are the same length. So these are both called isosceles triangles. An isosceles triangle has at least two congruent sides. At least two. So this triangle has two congruent sides, it's isosceles. This triangle has two congruent sides, it's isosceles. Don't get used to seeing a triangle standing up. This one, a lot of times I tell students to think about like a pine tree. But isosceles triangles, as you can see, aren't always going to be standing straight up. They may be off to the side, like this, or rotated, something like that. And then we have the last triangle that we classify based on side, and that's the equilateral triangle. Now, every single equilateral triangle has three sides that are the same length. And so we could say three congruent sides. We can also classify triangles based on the measures of their angles. This triangle is an acute triangle. In an acute triangle, all three angles are acute. This would be a good time for me to tell you that in every single triangle, regardless of the type of triangle, regardless of the size of the triangle, in every single triangle, the measures of the three angles inside it will always add up to 180 degrees. So that would be a really good thing to put in your notes, 180 total. The interior angles, so this angle plus this angle plus this angle will equal 180 degrees. And so in this triangle, we're not looking at the measures of its sides, we're looking at the three angles. And all three of these are less than 90 degrees, and so because all three are less than 90 degrees, they're acute, and because all three are acute, it's an acute triangle. Another example is an obtuse triangle. Now this is an example of an obtuse triangle where there is exactly one obtuse angle. Now it's not possible to have two obtuse angles because an obtuse angle is one that is greater than 90 degrees. And all triangles have interior angles that add up to 180. So if there is one obtuse angle in a triangle greater than 90 degrees, the other two need to be less than 90 degrees each. So they'll both be acute. So every obtuse triangle has exactly one obtuse angle, and that would be this angle right here. And then lastly, we have a right triangle. And a right triangle has exactly one right angle. it would look just like this. A right angle is an angle that measures 90 degrees, and there can only be one. Imagine, could there be two? If you could try to draw one, it would look like, well, there's one right angle. If you drew another right angle, you would notice that these two sides are parallel, and they would never touch, because this 90-degree angle plus this 90-degree angle is already 180. So it's not possible to have more than one 90-degree angle in a triangle. So again, exactly one right angle. So we're just going to practice a little bit, and we're going to classify each triangle based on the length of its sides and the measure of its angles. Each of these should have two names. So if I look at this triangle, I don't see any tick marks, but it doesn't look to me like any of the sides are the same length. If the sides are all different lengths, the first name we can give this is scalene. And then we look at the angles. I see an acute angle here, an acute angle here, but this angle is larger than 90 degrees. And so because it's larger than 90 degrees, it's obtuse. So this is a scalene obtuse triangle. Or you could say obtuse scalene, either way. But this triangle has two names. If I look at example B, I do notice some tick marks here which tell me that this side is congruent to this side. But these two sides are shorter than this third side. So based on the length of sides, I know that this triangle is isosceles. I also know, because it has the symbol for a right angle, that this is a right triangle. So it's an isosceles right triangle. Good. Here I know that it's a right triangle right away because it tells me that there's one right angle, so we can put right. But as I look at the lengths of the sides, I know this is the short side, this side's longer than this one, and then this one, this side is definitely longer a little bit than that one. And it happens to be an attribute of a right triangle. This side that's opposite of the right angle is called the hypotenuse. You don't need to know that right now, but the hypotenuse is always the longest side of a right triangle. So knowing that, I know that this side is longer than that side, just in case you weren't sure. And so that makes this a right scalene triangle. And then lastly, I have triangle D. These two sides are the same length, and they're obviously shorter than this third side, so we will call this isosceles. And then if we look at the angles, I see acute, acute, and again, larger than 90 degrees. So we have an isosceles obtuse triangle. Take one attribute at a time, and keep in mind, use your notes. You've got your three names for the sides, three names for the angles. You don't ever give a triangle two angle names or two side names. That's a common mistake. So remember, it's one name based on the lengths of the sides and one name based on the measures of the angles. And then lastly, without looking at a triangle, we can classify it if we know their measures. So these triangles, we are given lengths of sides. So this asks us to classify each triangle according to the lengths of its sides. So only one name for each one. If a triangle has sides that measure 6 feet, 9 feet, and 12 feet, well, all three measures are different. So that is a scalene triangle. So we'll just go ahead and write in scalene. In example B, all three sides are 2 inches. If every side of the triangle is the same, if they're all congruent, then that is an equilateral triangle. And then lastly, triangle C has 2 sides that measure 7.4 miles. What kinds of triangles would you measure in miles? I guess plots of land could be measured in miles. So that might be a triangular piece of land. Something to think about. So 7.4 miles, 7 4/10 miles, and 4 miles. Well, 2 sides are the same length, the other is different. So we're going to call this isosceles. Okay. Now we have to classify each triangle according to the measures of its angles. So in here, I have a 105-degree angle, a 38-degree angle, and a 37-degree angle. Keep in mind, all three angles add up to what? 180 degrees. So you can always double check to make sure that's true. But if I have one angle that's larger than 90 degrees, then that angle is obtuse, meaning that this is an obtuse triangle. In example B, I have a 45, 90, and 45 degree angle. Well, that 90 degree angle, that's my clue. 90 degrees is a right angle. So because I have my one right angle, I have a right triangle. And then lastly, I have a 40 degree angle, a 60 degree angle, and an 80 degree angle in this triangle. All three of them are acute, so I know it's an acute triangle. And I also notice there's not a 90 degree angle, so it's not a right triangle. And there's not an obtuse angle, so it's not an obtuse triangle. So process of elimination also tells me this is an acute triangle.